Make sure I'm recording. It doesn't tell me if I'm recording. I think I am now. Does it say it's recording elsewhere?
Yeah, in the
Thank you.
corner.
I get no indication, it seems. So yeah, for everyone just joining the recording, my name is Bennett, president of VEX Robotics. Obviously, this is a new format for us, but we're going to go over a lot of information about how this semester will work for the club. There we go, got the slides. So we're going to be going over sort of what the group generally does, how that falls into our mission before introducing the Eboard. Many of the roles are going to have some updates about what their plans are for the semester and what changes are occurring. And after that point, we'll take some questions both through the chat or just if people have live questions. We'll then present all the projects that are going on currently. And again, take questions after those. And then finally introduce the workshop series this semester, which we're really excited to share with you all. So I think we'll get started with just, what does VEX Robotics do as a club? We kind of boil it down into three main points where we coordinate student-led robotics projects. The group then supports these projects by providing funding and storage and perhaps a shared community, people interested in these topics. And then we also work to educate our members in robotics-related tools and techniques. So let's try to break down each of these things and see actually how we do that. For the projects, this is kind of the core of the group. Members can join ongoing projects or members can start their own new projects. Each project typically has one project leader that's kind of the contact for the project and make sure things are organized at the higher level to the overall organization. Project leaders attend Eboard meetings and they're going to track their project meetings attendance this semester so that we can have a more accurate representation of the club's active membership. And then finally, if you're interested in starting a new project, that is definitely an option. We'll hear more about that a bit later from Fran, our vice president. But be aware that we'll have a forum and want to support you guys if you're wanting to do that. Yeah. One way we do support you in starting projects is obviously funding. The overall club gets funding from two main sources, the Students Association and HAGEM. How this typically works is each semester we apply for funding using a supplemental request. So basically each project will get together what they need, get a list of supplies, equipment, and bring that to our business manager, who will then put it all together and bring a joint proposal to SA or HAGEM, whoever we're talking to. This semester, obviously things are different, but we'll have some information about fundraising and how we're going to handle that coming up. For now, let's finish off with what the group does. Third part of support, we have storage in both Wegmans with Swipe Access, and we have storage in Redner. Typically, we can also reserve meeting spaces, but this semester, again, changes because of COVID. We'll talk about exactly how this will change in just a few slides. And the final piece of our mission really is our educational aspects. We host workshops to educate on these things. We want our members to be learning, and we want our members to be able to succeed in the projects that they're starting or joining. And then we also host panels and we have outreach events like Family or Spooky Science Day, which we've been a part of for a number of years. So let's get into some brass tacks. What does this semester look like? We still have our storage in Wegmans and Redner. In terms of meetings, we are still having these conversations. We do not have clear answers yet. Even into the day, I'm getting emails about, for some context, I mentioned we're talking with HAGEM, we're talking with Computer Science Department, we're talking with Redner, and we're talking with SA about where we can meet and how we can do so safely. There are a number of options. It seems like it may be possible for some projects to be working in person with 1, 2, 3 people at once. Scheduling these things, organizing these things, this is ongoing, but it does seem like a possibility, which I think is better news than it's definitely out of the question. And there are also, of course, options that people can just work remotely. We have some projects this summer that have already started working through that format. So Fran or Joe, would you want to speak on your experience with that?
Yeah, I can speak a little bit. I'll talk for many other occasions tonight, but quick introduction, I'm Joe Vaccarell, I'm the workshop coordinator. But on this topic specifically, yes, so we met a lot over the summer with Handbot and the starting of the VEX team. And so we realized, and this is a point I'll reiterate many times, that even if you're virtual, you can do many things. And especially, if you have a passionate group of people that want to get something done, you'll get it done basically. So my biggest thing is, as stated here, Zoom and Discord were, incredibly useful services, especially Discord we use for meeting throughout the summer. We meet weekly on Saturdays, and Discord allowed us to keep our members up to date, allowed us to send updates to each other. A similar program could be Slack. I personally have a preference for Discord because it also incorporates the messaging, the video call and the voice call aspect. For design, the question would be, not the question. The topic is related to Fusion. We use Fusion a lot over the summer, especially I've used Fusion a lot, and it's great because they have shared projects, which basically that means is, as stated here, you can have like a folder, but you can all access it as a group, and you can add parts and modify things, much like a OneDrive, but for CAD. So Fusion's a great tool as well. Asana is something we've relatively recently transitioned to. And basically what that allows you to do is, set up a variety of tasks that you need to complete. And then team members can come in and basically assign them as complete or in progress or, need to get this done. It's great for productivity management and a variety of other things, just keeping things in running smoothly per se. And so, yeah, there's lots of opportunities to, especially during the semester, use our online resources to the best. So yeah, that's all I have to say.
Thank you for that. Kind of another obvious note, anyone working in software, computer science, there are very great tools to collaborate there with GitHub and other things. So, don't worry there. So we've covered a lot of things, but you might have still have some questions. We're going to now go through the e-board and just share some more updates from each of the positions, introduce everyone. And after that, I think it'll be a lot more clear, what questions still remain. So to start, I guess, I am, the president of the group. My name is Bennett, again, majoring in computer science and linguistics, and I'm a third-year student. My role on the e-board is to generally kind of abstractly lead. This can involve a lot of emails, delegation, messages, and then I also represent the club to faculty and administration. Again, more emails. But I do have some concrete updates for us this semester. We're working on bringing on Professor Thomas Howard as our faculty advisor. This is following the passing of Professor Randall Nelson, who was with the club for a number of years. I think he was involved in its foundation, but he passed away in April, and we're still reeling from finding replacements for his advising, and we were in a space which he worked with, so navigating stuff there. That's kind of the second point, really. We are navigating our storage meeting details still. Emails in today are arising, but it seems like things will be plausible. And again, we have a lot of things that we can do virtually up until we get these questions kind of ironed out. Finally, I've been part of the workshop team this summer, developing, I think, some very interesting content, a lot of it about programming and the computer science side of the workshops, making somewhat intelligent systems. And then that's also kind of the project I'm working on, Navbot. I'm the project leader for this. You'll hear much more about it later, but much enjoying that over the last year as well. Yeah. I would like to introduce our vice president, Fran.
Hello guys, I'm Francesca Dashak, but you can call me Fran, it's easier. I'm majoring in mechanical engineering, minoring in computer science, or maybe astronomy, or maybe both, we don't know. Who knows? I'm a sophomore, so my role in this club is to assist the president as vice president. Also, I intend to help projects coordinate smoothly. It seems that we could benefit a lot from like a centralized structure where projects can talk to each other and benefit from each other's experience, basically. This semester I have a lot of plans. As I just said, one of mine is streamlining communication and coordination between projects and project leaders. Basically, it's pretty self-explanatory. I just think that we could work a lot more smoothly with each other. I also want to organize an official contacts list for UR Robotics. This could be really beneficial because professors obviously know a lot and we could definitely benefit from their experience. Also, there are career professionals in the local community I think we could reach out to. They would definitely be helpful contacts for us. Like Bennett, I'm also assisting in the workshops for UR Robotics. I'm teaching a workshop on computer-aided design, or CAD, in Fusion 360, which is a program most of us use. I don't know about all of us, but a lot of us. And eventually, I intend to teach a workshop on finite element analysis, or FEA. That's basically simulations, shape optimization, stuff like that. This year, I'm also leading Handbot for the second year, which is fun. Really great project. You'll also find out a lot about that in a bit. I'm starting a VEX team with Joe. We are going to be co-captains, which will be super fun. And we're going to be planning for next year's competitive season because obviously this year coronavirus will hinder us a little bit. I'm also functioning as mechanical lead for Mate, which you will also find out in a little bit. Yeah, so that's me.
All right, hi guys. My name is Ryan, and I am the business manager for Robotics. I am a junior majoring in ECE, and I am also minoring in Chinese, but I have a lot of different interests, such as, I used to play with Wind Symphony. I've done chamber ensemble, I don't know, jack of all trades. And my role, like I said, is as business manager, which is more specifically to manage the club funds and the financial aspects of our events, whether we need to buy like refreshments or, get gifts for speakers and stuff like that, or if we want to fund our own travel to places, rip coronavirus. And basically my plan is to first drop a timeline of events and project deadlines to make sure that we'll be able to get our funding on time this year. And then after that, I'll make sure we can secure funding for things like 3D printing or other project materials from HAGEM, which for the newbies is the School of Engineering Care. I'd also like to cooperate with project leaders on unforeseen expenses. So future project leaders, if you find yourself all of a sudden needing a $200 screw for some reason, then you can go ahead and reach out to me. And I would also like to begin the process of official sponsorship from the ECE and CS departments, as opposed to getting our funding from the Student Association, which we are currently doing. And I will also like to tell you guys about useless facts about porcupines. And so, let's make things engaging, guys. Contact me if you have any questions or concerns. That's my email right there. I don't know, other stuff I want to do, maybe I've been thinking about starting an optical oriented project this year. I'm not quite sure the specifics yet. But yeah, if you guys are interested, then I'd definitely like to do that. And I might, depending if Joe lets me or not, try and run a workshop on something ECE focused, if he needs any kind of help on that. So yeah, that's me. If you see me around campus, tell me hello. If you guys have any questions, reach out to me. Thank you.
I'm not quite sure who's in the call or not.
Yeah. And hi, my name is Ian Douglas. I am your secretary for this club. I'm a sophomore and an undeclared major. So kind of my plan for this semester is to kind of make things more fun and interactive, especially on the emailing side. As you can kind of see from my emails, there will be memes included. So it'll definitely be a kind of fun thing that spikes things up. So feel free to contact me if you want questions regarding where clubs are meeting or where can you find X, Y, and Z. That should be a help to you. Thank you.
Hello. I introduced myself earlier a little bit, but same thing. My name's Joe Vaccarello, and as stated here, I am the workshop coordinator. I am also a mechanical engineering major with minors in environmental engineering and Spanish. Something else interesting about me is I like 3D printing. As you get to know me, if you join the team, that's a big thing I like to talk about. Some other interesting things about me is that I am a I am a member of a few different teams. I am a member of Navbot. I did the mechanical design on that. I'm also a member from Handbot. That's something very dear to my heart. And then I'm also starting the VEX team with Fran. So my role as a workshop coordinator specifically is this year what I wanted to do was create a series of workshops which will teach students basically the introductions to robotics. And I'm going to talk about this near the end of the presentation more. Basically what it is, we want everyone to join this team and to start things off with a level playing field. And what that means is, we want to teach you these skills throughout like a couple first weeks of the semester. And that is like what this is enabling us to do. So my plans, as stated here, is, I want to present these. I'm going to be presenting 2 of them in total. There's 6 in total. And I will also start planning out the spring workshops, because the idea is that we want to have workshops for every semester. Those will be a little bit more intermediate, but same thing. This first set is more for beginners and people who also intermediates as well. So yeah, that's all about me.
Hi everyone, I'm Tram. I'm a BME Econ major with a Chemie and Environmental Engineering minor. I'm currently the lab coordinator, and also I lead the VEX Robotics team. Speaking of, I guess, so my job is to make sure that you guys have access to materials and the tools that you need to make your own projects or to continue the current projects. As for Retner, what we currently have in Retner is a CR10 3 printer, which is very easy for us to access because it belongs to makers, but we have full access to that. There's a Stratasys printer, which belongs to the school, which has about 2 to 10 days turnaround if you want to print something on that. There's a whole workshop with power tools, with lathes, end mill, saws, whatever you need. And there's also a CNC there. It's about, I'd say, I don't know, I'd say 1 feet, 2 feet by 2 feet. It's not that big, but it's enough for most projects. My plans this semester is to make sure that our club has access to the things we need in Retner, as well as the materials to do the projects. Combat-wise, I plan to finish wrapping up all our current bots and also start building all the bots we have in progress since a year or 2 ago. Since now we actually have time, we can actually revise a lot of the in-progress bots that never got finished because somewhere along the line we maybe found a problem with the design and did not fix it in time. I guess that's it from me.
Thank you.
Hi, my name is Rachel, and I'm the outreach chair. So I'm a junior, and I'm majoring in computer science, but I'm also getting a minor in ECE and art, and maybe more. I don't know. I'm also a member of Combat Robotics. And so basically, the outreach chair is going to be a new position. And I'm going to serve as the main point of contact for the external communication for our robotics club. And so my plans for this semester to contact other clubs to organize co-sponsorships, and then also contact possible sponsors or suppliers for our projects. And I also want to organize community outreach events or programs, especially educational ones. I know Bennett mentioned the Spooky Science Day, but there's also other opportunities teaching high schoolers or other students code or how to build simple robots. And I also plan to contact faculty to join our Robotics in Rochester panel, which will be in November, as well as hosting online talks, which ideally will be once a month. So that's a total of 2 to 3 this semester. And I'm kind of looking to know if people are looking for faculty or some other topics that people want to hear about, and also looking for ideas beyond Professors Howard and Pollocky and Shum, if people are interested in other faculty and or maybe even graduate students or alumni. So yeah, that's my plan for this semester.
Well, it's tough batting cleanup for those people, so I'll have to go. So my name is Will Phillips. I'm a junior. I'm an EC major. I was going to minor in CS, but I'm gonna end up 1 class short. And I'm the co-lead of the solar team that we'll talk about in a little bit. So this position, like Rachel's, is a new position to the club. I, as fundraising chair, would suggest I'm going to be working with outside sources and U of R admin in order to try to gain more funding for our club. So for the semester, my main goals are crowdfunding for the first time couple semesters, both through more traditional methods, you know, probably from high school in terms of like Chipotle or and like life systems like that, and more like newfangled methods like having an alumni newsletter and doing classic crowdfunding. So like U of R has its own crowdfunding platform, so we don't have to go through GoFundMe or anything like that. Contact me if your project needs funding and like a club can't guarantee, or if you have a reach goal for a piece of equipment. Yeah, so contact me or Ryan. I'll put my email in the chat as well. Sorry, I didn't put it on the slide. But yeah, so think about this as the club should be your main source, but this is more like supplemental or again, more reach goals. So we're going to be trying to hit the ground running soon. So check your email, probably work with Ian on making sure everyone knows about our campaigns. And that's really it for me.
Okay, I do think that is the Eboard. So definitely covered a lot of information just now. We'll send a summary after this meeting so people, you know, can pick out the important parts. But if anyone has any questions right now, we have a few minutes for that. Let us know in the chat, or you can just unmute your mic. So question from Tiffany. I don't know if the recording shows this. So do we have to choose one project, or can we be involved in multiple? Can you try them out? Yeah, it's actually very typical for like, especially beginning students to try out, you know, look into a few different projects in the beginning. You can really join as many projects as you have time for. That does, you know, vary from person to person. Obviously we have Fran and Joe who are both involved in 2 to 3 projects, or 3 to 2 respectively. It's definitely feasible. And I found that, you know, it can be easier to put more effort into a single project, of course, as well. But these are definitely, you know, decisions you're making as college students already. So, you know, nothing new there. There'll be a few other question segments as well. So I think we can maybe keep moving. But I guess it's good that we've answered a lot of stuff at least. So yeah, and now we're just kind of to overview each project. We've kind of split them up into competitive and then non-competitive projects, and you'll get to see kind of the full spectrum of what projects are continuing right now, and that might give you an idea of, you know, if there's something that you want to do, is it being done here quite or not, and maybe go from there. So first off, I think it is combat.
Yep. Can you move to the next slide? So combat robotics is, as it sounds, is basically building combat robots. I don't know if anyone has watched the show BattleBots, but it's basically BattleBots, but on a smaller scale. So BattleBots are 250-pound class. You compete at the 30-pound, 12-pound, 3-pound, and 1-pound weight class, so much, much smaller. We've been around for 3 years. The group, actually 4, this is the 4th year. The group was started by 2 seniors and a junior when I first joined, who've now all have graduated. One of the seniors who founded the team is now actually on the official BattleBots team for blood sports. He will be competing like this fall actually. So I guess good luck to him, and I hope his team does well. The first bot we've ever built was a 30-pound bot, which was named Karma. It was a flipper bot. It did not do very well. It was a first bot. Since then, we've built more bots. We've built Conduit, which is a 30-pound bot. I think we've rebuilt Conduit 2 or 3 times. We've rebuilt Top Kill, which is a 3-pound bot, about 5 times. Omni was a 3-pound bot, was built once. The idea didn't work out very well, so we scrapped it. Here's my bot, which is 1 pound. I call him Will, but it's short for like, if there is a will, there's a way, because I basically tried to put some unfeasible ideas in a bot and make it work, and it actually worked. So there's that. There's also Bites the Dust, which was literally a Dollar Tree dustpan on wheels. You go to the next slide. So the goals for this year is that we want to finish building the wall. So the wall is basically a 12-pound bot, and the concept behind the wall is basically a wall that moves towards the other enemy bots, and because it's a wall, they kind of can't destroy it. That was the idea behind it. Like, how would you destroy a brick wall? So it's basically a giant, big, and durable piece of plastic on wheels. So it's in progress. We have most of the materials on it. We just need to actually start building. We also want to finish CADing and building a 3-pound horizontal kinetic spinner and a 3-pound vertical kinetic spinner. We have the most important part for those, which is the weapon and the actual motor used to drive the weapon. And we also have the motors to actually drive the bot, but we don't have an idea of what the bot specifically looks like. We have a general idea, but we don't actually have a design. So we definitely want to start and finish CADing both of those bots. We want to redesign the 30-pound bot conduit, or maybe make a new bot, 30-pound bot by itself. Conduit has been rebuilt 2 times with varying degrees of success, and we've been debating the team whether or not to continue that design or to completely scrap it. We don't know. We'll have to see, because now we have a lot of time to actually do a lot of analysis on whether or not that design is effective. I personally want to slim down Will a little bit. It's about an ounce overweight, and while most of the rule in the weight class are generally flexible, the smaller the weight class, the less flexible they are and how much weight they allow you to go over. So right now it's a little bit overweight. Last time I competed with Will, they let me go, but I doubt the next competition will be as lenient, so I don't know. And I also want to help new members, design and make your own bots. So yeah. So the roles needed for our club is, number one, we need a fabricator. So basically someone who is shop trained so they can make parts for the robots. That includes cutting, machining, milling, lathing parts. We also need a CAD person. So that person would help design the robot, make parts, design parts, 3D print. We also need an electronics person, which basically manages the wiring and the electrical components of the bot. You're basically shoving a lot of wires inside a very small and tight cramped space. So we need someone who really knows what they're doing and make sure the circuit does not short circuit with everything in such close proximity. We also just need a general assembly member just to assemble the bot together. So things you would do would be like drilling holes into the top and the bottom panels of the bots, screwing things together. We also make 3D printed parts that need heat sinks in, so you can actually screw things together. You also want someone to deburr the parts, because after you machine it, there's burrs which will cut you if you're not careful. Sanding, hammering, general things. And we also need a driver, so the one who drives the bot. So this is only applicable to competitions. That's when you need a dedicated and really skilled driver to actually drive the bots. But right now, there's currently a university ban on all university-sponsored travels. We actually can't compete, so that is currently to be decided. But if that opens up again, we definitely are looking for drivers, because there are more bots than drivers right now. We can go to the next slide. So right now, the role requirements for the roles I mentioned are: for the fabricator, you need to be machine shop trained. So either by taking the class ES141 or being trained directly by Jim. If anyone is interested in being shop trained, they can contact me and I'll try and set up something with Jim. Technically speaking, you have to take ES41 to be allowed in the machine shop and use all the fancy tools in there. But because I guess of the club, and because also I'm one of the few people on campus authorized to swipe and open the shop doors, I can request for you guys to be trained and then be there, and we can actually use the shop tools. CAD person, basically you just need a computer that can run Fusion 360. CAD skills can be taught either if you're in a big pinch in time, I can teach them, but soon after we're going to have a workshop on CAD, so that definitely will be taught by the club. Electronics person, we just need someone who knows how to solder. We can definitely teach you how to solder. It's not difficult, but it's just mainly knowing how to solder, how to know what's a good solder, what's a bad solder, that kind of thing. And generally, general assembly, we just need hands, basically. It's not, a hard job, drilling, hammering, that kind of thing. We just want, I guess, people to come help us, because it's generally a lot of work. And whatever you need to know, we'll teach you. We're not specific on background as long as you have passion and you're willing to show up to the club meetings and willing to show up when we need help. There's always a place for you on the team, no matter what team you're on, no matter what major, and no matter what skills you have. We'll probably teach you what you need. Can you move on? And we hope that you can learn various skills needed to make your own bots from scratch, whether or not it's combat in the future. So, because a lot of skills being taught in combat is like machining, CADing, 3D printing, finite element analysis, CNC, that kind of thing. So we usually work at our own pace, so we have no set meeting time. So if you're interested, feel free to email me at the email on the screen.
Next up is Mate Project.
Oh, let's go. So, hey guys, my name is Adham. I'm the project leader for MATE. MATE stands for Marine Advanced Technology Education. It's actually a company or an organization that does competitions for like high school students and university students to build submarines. Each year we have to do like a different mission. This year we're more aimed at climate change, like collecting plastic debris from underwater, taking samples from like the ground, cleaning stuff, and surveying a lot of stuff. And there's going to be a lot of autonomous work, a lot of camera work, and a lot of like gripper work, as you can see in our design. This is one of our like the design like that is next to Mate, or like team leaders apparently. That's one of the designs we have, but it's not the final one. Like through these pictures that are some of our team leaders. You have Fran down there next to Kevin, and that's in our lab that we don't have access to anymore thanks to COVID. And then in the second picture, there is Sheeta working on fabricating some stuff. And then this is me actually with one of my first submarines when I used to build them back in my home country in Egypt. Can you go to the next slide? Yeah, so Mate is, the Mate competition is actually competitive, but now we started to think bigger that we don't just want to compete, we also want to work on research. So there's going to be two parts of Mate, or the group. Mate is just like a temporary name that we have right now, but I'm pretty sure we're going to like change it soon. So the competitive part of the competition that we want to join is in June, in the 25th of June, usually every year. We will be hopefully traveling to the competition if the pandemic is over. And usually the work for the competition starts from like October till June, where we get like a lot of updates regularly from the university and so on to compete and just learn about stuff. And the research is going to be all year long. We're basically just doing a lot of research about what's going on in Lake Ontario, what's going on in River Genesee that a submarine can actually help with. And apparently there is a lot of stuff that we can work with. And right now we're trying to even like contact people within the state to help with what we can do. But that's going to be something for some of our team leaders to just discuss more in the presentation. So something to know that Mate is just a huge melting pot of a lot of backgrounds. We have people from MECI, you have people from CS, we have people from, I think somebody's calling me. I am so sorry for that. Let me just mute my close Facebook. Here we go. Yeah, we have a lot of backgrounds. We have a lot of people with different skills, but just don't get overwhelmed. If you come to Mate, no matter what your background is, we're going to pick you from there. Even if it's zero, we're just going to help you out. Even if it's something not related to your major, you can always learn. And we're going to have hopefully sessions in the future about like how to do different things and just get you like sort of on board with everything that is going on. Without further ado, I think I'm just gonna go to the next, and then Shira's gonna take over. She's the team leader for the fabrication team.
Hi, I'm Shira. I'm a junior in MECI, and yeah, I'm kind of in charge on the fabrication of the parts for the Mate ROV. So we basically have two things that are separate. One is the machining, which we do in the Retner workshop with Jim Malkin, and then we have also the more the frame and the motor mounts and the arm, which we're actually just CNC machine cutting or laser engraving, because we have that, all the school has that machine. So you'll see like the cap at the top right. That's something that we're machining at Bretner. We're actually in the previous slide, you could see like the picture of me machining was of that, of the cap. The lower left is how it looks. Then we have the picture of like the frame. Those are all 2D things that we're actually doing out of polypropylene with the CNC machine with also Jim's help. For laser engraving, we haven't been sure. We're figuring out which is the best method. So basically, I'm kind of figuring out, well, I and the team figuring out how to do each of the parts, like we're making all of the parts for our ROV, and kind of even like if you're not machine trained, I am, and quite a few members are, like as long as you're with us, we can show you methods on how to do it, and then also learning how to CNC cut, the method, the process, programs, and then, creating the parts and putting it all together. Next.
Hi guys, I'm Fran. I'm the vice president, as I think we all know. Okay. I'm in charge of the design aspect of MATE, so this is what it is. Basically, it includes 3 different sections of design. We want to design the structure of the ROV, so that's like the chassis. It's the sheets made out of polypropylene, like Shira just said. We want it to be able to be accessed easily and assembled easily, so that's our goal for that. Then next, we have to design the interaction. This is the interaction between the ROV and any game elements or elements in the wild that we're trying to study using our ROV. Usually this involves like a claw-like structure that interacts with things in water, and also cameras so that we can see where the ROV is at this time and see what we're grabbing. Thirdly, and possibly the most exciting of the 3, in my opinion, is the ROV optimization. This is where we use finite element analysis, which is my big passion, to make our chassis and our elements of our ROV like more optimized, basically, as it implies. We're looking to make them lighter, make them stronger, make them more robust, and we use a lot of CAD and programs such as Fusion 360 and OpenFOAM to see how we're doing that and how we can improve it. Next. Yeah, so basically our process is to brainstorm first, then CAD, then analyze. So brainstorming basically involves the whole team gets together and we all talk about the game problem or any problems we're trying to fix with our ROV. So what do we want the ROV to do, basically? This is like a big list of things and we come up with a million different ways to solve it. And then we will like gradually narrow down the options until we start CADing. CAD is not a verb for the record, but I do use it as a verb, so just get ready for that. We CAD the ROV using Fusion 360. We basically make a virtual model of our ROV and we can change sizes and see how things will fit together properly, see how it will interact with other things and if the like designs will actually work. We also, not only do we CAD the frame, we also CAD all of the elements on the ROV. Right, CAD is computer-aided designing. We will also use it to develop any claws or where the camera will be, stuff like that. It's basically just planning out what we will do with the ROV. Then thirdly, we analyze our design. Like I said before, we use finite element analysis to see how it'll work. This will mostly include OpenFOAM this year. Hopefully, we'll be able to get some more expensive programs, although they do go for a lot of money, basically. But yeah, the whole goal is to make the ROV more efficient and cooler. Next. So this is our timeline so far. Obviously, this is basically what we've achieved it, yeah. In December, we started brainstorming our design. That's basically when I joined MATE, so I don't really have any recollection of what happened before that because I wasn't there. But we came up with what we want our ROV to achieve, and we wrote it all down and we planned it out. As you can see, there's a drawing from Shira. Next, we started CADing some prototypes. So as you can see underneath that, it's like the top plate of our design. Basically, we were just trying to figure out what the basic shape of our ROV will be. And as you can see in the middle, there's like a weird hole. That's so the water can flow through. And the goal is to basically find out how we can allow the ROV to move through the water well. In July, we started recruiting for new members. So this is during the summer. We actually worked through coronavirus times, which was pretty impressive in my opinion. We recruited new members and began working on the second version of our design. So underneath that, you can see V1. It's basically all of the blue and yellow parts are polypropylene, and they're going to be, well, they would have been CNC cut. And we took this design and tried to make it better in V2, which we are almost finished with. It is now September. We should be finished with it in 2 weeks, and we're going to start fabricating from
there. Can you go back, please? I think we skipped someone. Slide. No, go back again. Back again. Back again. Yep. No. Yep. Here we go. Okay.
Hey, so my name is Thomas, and I'm the head or leader for the Environmental Research Division of MATE. And what essentially this is it was somewhat born and bred from the fact that, well, in 2 weeks, or we will have a robot for this competition, and we're also conveniently next to a lake, Lake Ontario, and the Genesee. So yeah, what if we combine those two and use a robot for the purposes of just researching or doing stuff in those bodies of liquid? So currently we're in the process of just figuring out what we want to do, which at the moment is the two plans we have is to use the ROV and its camera to study or count populations of organisms within the Genesee, whether this is in comparison to what's previously known, or to help hopefully New York State with what they do annually. And currently our timeline is going to, figure out what we're doing and get a concrete idea of what we want to do with the robot, which is what we're doing now. And then after that, our plan is to get a professor or someone else that's interested, mainly because professors here, they're a good resource, and we need both a sugar and knowledge daddy to fund and give knowledge to this project. And then after that, we need to just the plan is to hash out the final experimental design. So how we're going to set up what we're doing and what we need to add or modify from our competition ROV to, make it used for research. And then the plan is to actually use the ROV in this setting and hopefully gather data from that. And then eventually, do something with the data, whether that's publishing a paper, hopefully with a professor. That's one of the goals I hope to achieve, or giving it or using it, giving it to New York State government. We'll see. And that's the plan. We're likely going to, mainly because COVID is making a lot of things uncertain, my goal is to try and do all of this in the first semester. So if we get kicked off campus second semester, at least we have stuff to work with. Because you can't really put a robot in a river when you're all online. So I guess next 3 slides to, where this ends.
Just like we're gonna have an orientation for MATE. It's gonna be way longer. We're gonna cover everything that we've done in details, and then we're hopefully gonna sort you into teams, whatever you guys wanna do. I just sent a Discord link to our Discord. Just please join it if you're interested, and see you on Sunday the 13th at 5 p.m. if I'm correct. Team leaders, you can sort of confirm. Yes, it's 5 to 6:30. on Sunday the 13th. And thank you so much. I'm looking forward to seeing you guys in the meeting. Mm-hmm.
Yeah, that's the right time. Just wanted to confirm.
Thank you.
That's great. The next project is the solar drone project.
Hello. So I'm project lead. I'm Will. I spoke earlier. I'm going to be speaking with our co-lead George, so you get to know him a little. So George, do you mind unmuting yourself?
Yep. Hi, I'm George. I'm also on the solar drone project team. And basically some history of this project. The initial idea was just like, how can we use something like renewable energy, like solar power, to you know, extend the like usable time of a drone in the field. And some initial ideas were kind of, you know, we brainstormed and we threw some original ideas out the window because we, with the tools we had and, you know, the physics of the situation wouldn't really work out the way we wanted to. But now our goal has still kind of kept that, you know, energy maintenance in mind when you're out in the field, and that renewable energy idea. And the new idea is basically to have a drone that can have a place to land and charge off of some kind of like station that the station can charge from the sun, and it'll be renewable, and you can use it, you know, when a drone is out doing a mission for any kind of, you know, it could be like rescue or relief or something like that. You don't know how reliable your power is going to be. You'd want something like that in the field. So yeah, our current progress right now, we've done a lot of like designing and, you know, putting down the groundwork, and we've divided people basically into teams. There's people who are going to be working on that cart, which is going to be the station that the drone is going to land on to charge, and the solar array, so basically like the power aspect of it, you know, like how everything's going to be connected, and then like, you know, kind of part of that would be the like internal connections of the drone, so that, you know, we know when to switch things from charging and discharging and all that. And then eventually we want to kind of work on maybe, you know, working on our own drone specifically for this project. And right now we have pretty much all the parts we think we need. We hope we don't run into anything else. But this is supposed to be an exciting semester, because I'm hoping that by the end we can have something to, you know, we can test and see what we have to do to either improve it or what won't work. But yeah, we're pretty much going to be putting things together this semester and trying it out. So next slide, please. Yeah, so if you're looking to join, we really could use some outside perspective, because right now it's like a lot of EC majors who are, you know, kind of in like the same group of classes. And like, even if you're an EC major and you want to join, that'd be great, because we just need kind of more people with different perspectives to help, you know, cover our blind spots of places, because we're all new to this development process. And like I said, we're moving into building the cart. So if anyone, you know, is a mechie or has CAD experience or wants to learn that, we would love to help them do that, because none of us have done that kind of stuff before, and that's something that needs to get done. And, you know, we're going to need like CS and like people with that kind of skill to help program the drone, and like the cart itself is going to be able to need to be controlled and do a lot of input and output kind of thing, to, you know, figure out what it needs to do at any given time. And like I said, you know, we're mostly EC majors, but we'd love to have more people to keep working on this in an effective way. And the difficulty for any given position, I mean, we don't really know the CAD, but from what we're doing, it's not a lot of real mechanical parts, but you know, it's mostly going to be like a frame and stuff for driving the motors. And CS might get a little difficult depending on how far we want to reach with this. Right now, it shouldn't
you know, we have some things that we need to get done. That's going to be programming that, you know, you're going to be self-guided to kind of, we can help you and you can figure it out on your own. And but it's going to be smaller parts right now, but in the future we're looking to get a lot more like programming heavy. And yeah, like I said about EC and literally anyone else, we could really use some new people with different perspectives to help us out. So yeah, next slide, please. Yeah, here's just a general, you know, it's a really rough, a rough draft from a while back, but you know, kind of what I said, there's going to be a solar array, there's going to be a charge controller, and we're looking to do an inductive coupling so that, you know, it can charge without having to like plug into anything, which could be difficult. It just has to be nearby. And here's a picture of the gang working on something together. We have a good time. So yeah.
Yeah, I recommend. It's such a fun project. I like to think we're a good group of people. I'm a little biased because I'm obviously on the project, but really, if you have an interest, please stop by or email me here. George, would you mind putting your email as well? Like we're gonna be the main points of contact. Yeah, we have a WhatsApp, so just email me and I'll add you to that. So yeah. Feel free to DM me here as well. I can just directly add you.
I'd like to say, yeah, this is going to be the semester where things are really going to start picking up for this project. Hopefully we're going to, because I want to get something done. I want to have something to work with. We've done a lot of designing and I'm excited to get working on some testing.
All right. Yeah, the next project is Navbot. I'm the project leader for this project. Start my timer to make sure I'm not going too long. So we start with the idea. What if we make a robot to navigate indoors autonomously? It's a very short sentence, but it is not a simple sentence, as it turns out. And a broad idea, you know, we want to sense the world, we want to create some kind of plan, and then act accordingly without a human involved. And our first semester, we really ended up learning this is very difficult. Kind of as a model of how this might work, maybe we have some sensors, we're going to sense the world in some way with the robot, build a model of the world, and use that to then plan using some kind of algorithms, maybe A*. Let's say our plan is in the form of a path. We're then going to try to act using actuators, motors, to move the robot in such a way that it follows the path. And as we do that, we need, you know, some feedback control to make sure that we're maybe following the path accurately. All that's very abstract. In a few slides, we'll see how complex it gets. This is our team. We had a pretty great time up until March. We have Robert on the left, myself, Joe, and Ian. Had some good times, and following March, had some distant times as well. For our hardware so far, we have a 3-tier robot design. This was designed by Joe and then rendered, as it says, in Fusion 360. We have batteries on the bottom in general, alongside the motors and encoders. Looks like we're going to be using an H-bridge, not pictured, but you know, we've learned that it's necessary. In the middle, we have our compute, and on top, you know, will be our sensing. This is a LiDAR unit. It kind of spins out and shoots a laser into the world. And I kind of list those things down here. Specifically, Raspberry Pi and Arduino Nano will be our 2 microcontrollers on the system. The software approach gets a bit more complicated, but I've kind of written for myself, you know, to build intelligent systems, sufficient complexity is required. To make such complexity maybe more feasible, there's a software called ROS, which works on the idea of nodes. Let's say you have a bunch of different processes, each doing their little thing, and all these arrows are representing, you know, sending messages to each other. And so each little process only needs to deal with what am I doing and what topics are coming in and coming out of each of the nodes. ROS is used widely in research for robotics, and you will end up learning it a lot should you want to join the software team for this project. So let's look at, you know, what are some of these nodes doing? We have a simulator, which is using a differential drive motion model. Basically, the idea is if we have a robot with 2 wheels, it's very easy to separate driving forward and backward from turning in place. These are our linear and angular velocities. And it turns out you can form mathematical models for how the robot will then move, which is useful for then predicting our motion, you know, as we integrate over time, you know, what we're moving. We also can plan over currently an 8-connected grid. We're using A*, which is pretty simple CS stuff. And then there's an executive interface to specify, you know, here's a goal point, plan for where the robot currently is to this point constantly. And again, the process just handles that. Each of these things is kind of a self-contained unit, which is nice. Next up, how do we follow that path? Well, this is the problem of path following control. There's an algorithm called pure pursuit, which honestly, out of everything here, I think might be the most simple. We have a path, let's put a point on the path some distance in front of us and we'll drive towards it. That's all we do. And on the right, it turns out the way we drive towards it is some sort of circular arc, which has a unique solution regardless. Cool algorithm, I think. Our sensing, we have a laser rangefinder, as I mentioned. It's going to shoot lasers out at every single angle in the world. And based on how long it takes the light to reflect back, we can estimate, what is the distance to different obstacles in the world. And here we have those white points in simulation, which are showing that. But we also have on the right side, this is a real room being mapped. My hand is moving here. You can see some noise, but in general, I think it's cool that the red dots here, which are literally the laser points coming back to us, they're pretty consistent. You can clearly see how they're forming the shape of this room. And we're then able to map that into what areas are traversable. That algorithm is called occupancy grid mapping. Basically, you take the laser points and you ask, what is the probability of each cell of the world being occupied? Surprisingly, it's the shortest algorithm out of all of these, but a lot of algorithms clearly. Who knew? So this semester, what's left? I've mentioned that we have the LiDAR scanner. We also want a camera as just another sensor. There are two ways this can be used. Both are going to try to detect landmarks in the world. Let's say you print out some of these April tags that look like QR codes for robots. If you have a camera, you can sort of see where are the April tags in the image, and thus where is the camera and robot with relation to those April tags. And thus you can kind of localize with respect to the world. And in a harder case, you could use other items like corners or edges or certain objects in the world to localize with respect to. And that entire problem is called simultaneous localization and mapping, often abbreviated to SLAM, where we're going to integrate this motion stuff I've talked about and this sensing stuff to kind of estimate our location and the location of these objects in the world. Finally, at a lower level, I mentioned the motion commands. In order to actually turn those into like stable motor speeds, you need PID control, which is basically you put a sensor on the motor to tell how fast it's turning, and based on if it's turning too fast or slow, drive slower or faster accordingly. And of course, putting all this together is not to be underestimated, but we do have all of the parts. This kind of shows that where, we have the render from about March on the left, and this is the robot's current state on the right, where we actually have the Raspberry Pi and Arduino, in person here. The motors have a kind of janky setup, which we may, 3D print something Joe has designed for a better setup here, but we have all the parts. The LiDAR, as I've shown, we have it working in person. And it's really just a question of, controlling motors with an H-bridge and Arduino, doing PID control at that level. And then I showed all the simulation stuff. It's kind of just connecting that into the Raspberry Pi and making sure it can run, over a network. So really, like, in terms of software, it's just putting onto a system. Like a lot of these steps are, so far covered. Luckily, of course, we do have some resources to help us, continue pushing these things forward. There's a course, ECA 232, Autonomous Mobile Robotics, taught by Professor Howard, which covers a lot of these approaches, and these are two textbooks from the course. However, our project does differ from the course in some fundamental ways. For one, as I mentioned, we need to do this PID control. We need to cover the entire stack, or the entire stack of the robot. And this involves, working with the actual motors and the exact wiring and, computers that are involved. So a bit more involved there. And then, of course, we've also built this entire architecture from the ground up. So far it is in C++, but I'm interested in discussing with the group of moving to Python. Over the summer, I was able to re-implement all of this in like 2 weeks. And I think doing it again may be educational, get people, able to input on the system. And we can also revisit some of the decisions I hastily made, a few months ago. So, how do you join this? I'm looking for students in two main areas. I think in software, there's obviously a lot of opportunities here for us to, replace these algorithms, improve on them, fill in those few pieces I mentioned. If you're interested in computer vision, I think that's going to be a very important area for us this semester. And especially working with just a Raspberry Pi and its camera, it doesn't need to be applied to this project to be useful. How do we set a Raspberry Pi and its camera up? How do we get that data in a consistent way? These are interesting questions still to answer. If you have experience in Python or C++, that will be useful, but we will have workshops this semester which cover these things and introduce these tools. So, you don't need to worry. Of course, it's advanced stuff, but I doubt that any people are not thinking that based on this presentation so far. For the electric, we need to connect all these pieces together. If you're interested in feedback control, implementing the soldering here, there's a lot of steps to be done. And for hardware, I think finishing this current prototype is important, but in the future, a better mobility system may be interesting. Driving outdoors, driving over rough terrain. This could be in the future because the software will be, generalizable. That's kind of what this slide is all about. You know, we can improve our perception, improve our planning, improve our mobility. A lot of this project has led to opportunities for me already. I was doing research this summer, kind of in these topics. It's a graphic from I found interesting paper, kind of on what the next step of these algorithms are. But the cool part is, you know, once you've learned these steps here, I think a lot of the things we're doing really do apply to like the current approaches to self-driving cars, to what NASA does on Mars. I think that's awesome stuff. And then I finally leave us with a quote. You're in college once. What kind of problems are you working on? I was asked this like a year ago, right before I started this project, and I've been very happy with how it's gone so far. So if you're interested, feel free to reach out. Thank you.
Hey guys, it's Fran again. This is my project, your Handbot. So as you can see, I'm the project leader. I will also be presenting this with Joe, who is the executive assistant. You want to say hi, Joe?
I do, yes. Hello, once
Okay.
again. Yeah, we're going to go between slides a bit. Yeah.
Yeah.
Oh, go back one, sorry. Thank you. So for the first slide, we're a team of 9 sophomores with a passion for creating. As stated here, I think we have a pretty good team connection with each other, and I think anyone who joins the team will have a similar, you know, creation of friendship. We also have a team mascot. His name is Dr. Chipmunk. He's really cool, and it's really popular around our team. You go to the next slide.
So our team.
Yeah, you got it, friend.
Okay. Sorry. Our team is split into 2 groups, the hand team and the glove team. Later on, we'll tell you what our project is, but basically the hand team is mechanical. We're designing the hand and how it will function. And then the glove team is programming the hand and programming a sensor glove. Next. So yeah, here you can see our goals. Pretty cool. So on the base level, we basically want to design a robotic hand and a sensor glove. The robotic hand has to be able to grasp objects and perform hand motions that like humans can make normally, you know, stuff like that. The sensor glove is going to be something that the person wears on their hand, and and they can sense the hand motion of the wearer. We also are adding this new feature on the sensor glove called haptic vibration feedback. Basically, if you grab something with a robotic hand, you can feel it in your regular hand, which is inside the glove. So the second level of our goals are motion programming. So we want to be able to program the hand, the prosthetic hand, to move properly, you know, so possibly at the same time as the person with their hand in the glove, you know, yeah. Basically, the idea is so that you can move in real time with the robotic hand. And then the third goal for our club, for our group, I mean, is our robotic arm. So we want to be able to attach this hand to a robotic arm at some point, and the hand will be able to move in 3D space using the arm. And also the hand will be able to rotate like regular human hands, basically to make a human arm and hand. Next.
So we've been working on this for about a year now, I think. It's pretty crazy. So we've made a lot of strides in our designs. Picture to the left is some of our more initial designs, and as time went on, you'll see things improved and got better. Basically, back last September, we were working completely in CAD. As I said, we were brainstorming things. As time went on, we started to improve our designs based on, you know, feedback we got and, you know, being able to 3D print things and, you know, get them in a physical sense. And what was nice now, and what you'll see is more recently, one of our designs, the one I've been working on, we had the opportunity to print it. So I had the chance to actually print out the hand and have the opportunity to kind of mess around with it and do some testing. But as you'll see, like, you know, there's other designs from our fellow teammates that have, you know, going for the exact same goal. But we're kind of at a stage now where we're trying, I think somewhat soon we'll like focus in on one design. You can go next, I think. Friend, do you want to cover this one? Or?
Yeah, sure, I can cover it. So that was for the hand team. This is for the glove team. It's kind of similar though. Basically in September, I'm not on the glove team, but I'm speaking for them. They started brainstorming features for the glove, thinking about what sensors they can use and what they want the glove to be able to do, basically. By the time of December, we had started working on sensing. So we actually purchased the sensors and started using them to sense hand motion. As you can see underneath that, well, okay, first of all, on the bottom left is a terrible drawing of what the glove will look like at some point in the future. Next to it is next to it is a thing that shows basically a bend sensor on a finger. So when they bent their finger, the servo mimicked the movement. This will be like vital to how the hand will move later on. By the time of March, we started developing sensing into articulation. So you can see that in that GIF down there, but also we got a prototype of Joe's hand's finger, one individual finger, and we've been working on moving that using string and servos and stuff. Then coronavirus happened, so we all got sent home, but we did purchase parts for the glove team to use at home. The hand team couldn't really do much because only one of our members has a 3D printer as of right now, which is Joe, but everyone else doesn't, so we couldn't really do anything. But glove team bought a bunch of sensors and started testing stuff out, and they've been working with IMU's Hall sensors and servos. As you can see down below, it's a servo moving a hand in a waving motion, which is very nice. Next. So yeah, here you can see some of the different designs we've had so far. This is actually from earlier last year because coronavirus basically shut us off. But on the bottom left, you can see my design. It is different now and will be cooler. Top right is Joe's design. It looks a lot different now, but I mean, the idea is still the same. And on the bottom right is Ellen's design, which also we had to stop due to coronavirus, but we will be picking up again soon. Sorry, the light is very bad. Next. Yeah, Joe.
So yeah, this is what I was talking about earlier. This is like our first like physical prototype of a full hand, and this might be a little tacky, we'll see, but I actually have it right behind me. If anyone cares to see in the video camera, I actually have it mounted to a piece of wood. But the whole premise of it, and you can see here, is that you have these little strings, which is the system I designed, where when you pull the string, the finger pulls in, and then I set up the system of like little slots so you can set up certain distances to pull and grab onto something. What the idea of this all is that I wanted to start doing some testing, and these strings that pull the finger close will in one day be completed by servos that will be housed in like an arm module. The idea in the end is to create an a lower limb prosthetic that everything is enclosed right here. And so the one more point about how this works, if you're wondering, is when you pull on the finger, it doesn't just stay there after you're done. It goes back to its original state, and that's because at every axle there are these torque springs, which are just springs that make things retract, or strings that when they change their angle, like how they're angled, they go back to the original state, and so they go back to the 180. And yeah, so this is a good step for us, and I can't wait for what else we can make. You can go next. I can do this one. So basically, we need a few different people. The biggest thing we need is actually like some like ECE people. We have some great people already, but some help with that would be nice. And I'll go through all the list right now. For hand team, yes, anyone ME majors, anyone interested in CAD, 3D printing, something here. We love all of these topics, and you'll find many different things to make and do here regarding with that. And then with glove team, which regards the creation and programming of the glove, we'll need electrical engineering, EC, and then CS would be nice, because the end goal of mapping, the movement of the sensing of the glove to, the movement of the hand. But yeah, overall, we welcome anyone who wants to join. We'll definitely find a spot for you, and hopefully you'll have a great time. So yeah, next.
Which brings us to a really important point, and one of the tenets of our Handbot group. Basically, we are open to every single person, no matter how much you've done robotics in your life. I think it's really important that people are able to enter the robotics field at a level that is accessible to everyone. So we have positions available for anyone of any background or ability on both hand team and glove team. We will specifically work with you to make sure that you're able to work with us and like be a good part of the team, basically. Next. Yeah, so that's Handbot. Thanks for coming. You can scan that QR code in the corner and you can fill out our sign up orientation meeting survey thing. Basically, you just enter your email and then we put you in the Discord. But yeah, yeah, and also if you want to contact us, my email is right there. It's f-hack@u.rochester.edu. Cool, done. Not done. Next team. So Joe and I have also started a VEX team. In this one, we are co-captains. Basically, it's going to be a competitive team that will compete in the VEX U competition. Said compete 3 times in that sentence because it's important. VEX U is described on the next slide, actually. So next.
Hello, once again. Yes, me and Fran are co-captaining this team. Yes, for some details, VEX University, we recently found out about it. It's a university-based robotics competition. And if anyone here has experience in FIRST FTC, it is pretty similar. And, you know, so I think there's a lot of, you know, connections you can make and definitely skills if you want to continue some sort of, you know, a project like that. You'd be great on the team. You know, any robotics experience would be great, but if you don't have any, you know, we'd love to have you too, because, you know, we can definitely teach you. The biggest, similar to FIRST, every year the competition changes, and basically what we'll need to do is typically you'll need to build 1 large robot and then 1 small robot, and they'll need to complete a variety of tasks, which will be prescribed to us at the beginning of this semester, and then we'll have time to work on it and then do that stuff. The top right, you'll see, which is a topic that Fran covered earlier, is that yes, we will not be competing this year due to COVID, of course. However, as I said, there are many, many things to do, and there's many things we need to figure out and plan, and, you know, just so much research that can be completed online. Same thing, we had the experience of doing Handbot and VEX all over the summer. We literally met every single week, and it was good, you know. So it's just about, you know, staying on top of things, and if we're smart about it, then we can make some really good progress before the semesters, before next year when we need to compete. And what that includes is making a basic chassis, a series of sensors, a battery plus charging system, and then programming to run it all. And you can go next.
So like any competitive team, we basically have 5 main sections. We got design, control, outreach, documentation, and fabrication. Design is basically, you know, CAD, brainstorming, coming up with any mechanical design for the robot. Also simulation, believe it or not, we use that here too. The next segment is control. That's basically programming and also electrical components of the team. So that's wiring the robot and figuring out all of the different sensors and motors. Also programming the hub to control the robot and assisting with driver control. Okay, next is outreach. This is actually a really important part of the competition because you have to document everything that you've done as a team, and outreach like significantly increases your chances of winning the competition. Basically, you're supposed to go out into your community and try and educate others and educate yourself. Also fundraise and find sponsors in the community, but it's really good because it strengthens like the students' relationship with Rochester as a whole. And I mean, why are you coming here for school if you're not going to learn about Rochester? The next section is documentation, very important for competition. It's tedious, but it's worth it. Basically, you have to write down everything you do as a team and document everything effectively, basically. And the last section is fabrication. This is pretty self-explanatory. You use a machine shop and create the parts that we have designed. And yeah, we use 3D printing, CNC, laser cutting, and assembly. Next. So we have a basic timeline here. It's not like exactly accurate, but it's, I mean, you know, right now it's pretty accurate because we have no idea what's going to happen in the future. Basically, this summer we've been meeting as a team to organize what we're going to be doing this semester. Obviously, coronavirus unfolded pretty abruptly, so we've been trying to figure out how we can get on top of being a team this semester, and this is what we came up with basically. So September, November, we're going to be figuring out team organization. That's basically who's going to be in charge of what, how do we want to organize this team so that members can function effectively as a larger group. Around mid-September, we're going to start trying to figure out like CAD work, programming, and outreach. So outreach will be pretty simple. We'll just be reaching out to members of the community and seeing if they want to sponsor us or if they want us to go there and teach them stuff. We won't be traveling because coronavirus, but we will be setting up connections that will be really helpful for us in the future for our competition. CAD will be maybe creating like a prototype robot. We'll be working with assemblies and using joints to figure out how we can make mechanisms in the program. And programming, we'll be figuring out the programming language we want to use to code our robot. We haven't figured out 100% yet, but we will be training all of our members, hopefully, how to basically code in that program. Around mid-November, we'll start possibly purchasing materials for next season. We will need to have like a significant amount of materials to start our team, as you can imagine. But we're not 100% sure if we're going to be purchasing this semester or waiting until next year or next semester, I guess. Yeah, we'll be figuring that out later on. Late November, we'll start testing our manufacturing capabilities. So there are ways that we can try and manufacture some parts. We won't be making a full robot at this time because coronavirus, but we'll be trying something, you know, figuring out if we can use the CNC machine, laser cutting, 3D printing, like our prototypes. And then if COVID permits, late February, we can start building. It will not be a robot that we'll be using for this year's competition because we won't be competing, but we might be able to use the same chassis for next year, and we can at least program on this robot to see how it will work out next. Yeah. And as I said in Handbot, it pretty much goes for all of the teams I'm involved in. Being accessible to new roboticists is really important to us. And I mean, we are a new team, so it is a great time to start. We have positions for CAD programming, anyone who's good at documentation, anything like that. Yeah, contact us and you'll be able to join the team no matter how good you are or bad. Next. Yeah, and so thanks for coming to this. There's a QR code again. You can scan that and sign up for our orientation meeting, which we'll be having soon. And if you want to contact me, it's f-u.rochester.edu. I probably should have put Joe's email as well. Joe, can you type it in the chat? Thank you. Okay, yes. So that's it. Yep. Thanks for listening.
Okay, yeah. We have about 11 minutes until 6:30 when we said we'd be done. All we have left is to cover the workshops, which I don't know how long it will take, but are there any questions that are generally applicable for the projects? We can revisit that after the workshop section as well. Joe, do you just want to present on that?
Yeah, that sounds good. So to kind of detail into what my job is, it is this. What I did along with my team and I over the summer is we created a series of introductory robotics workshops to teach to basically the entirety of your, well, whoever on your robotics that wants to join and do these lessons. Basically what this entails is that we are going to be teaching you how to create a robotic arm that can intelligently move in 2D space. Basically what that means is there's two servos moving this arm, but you're moving it in such a way that is like intelligent. Instead of just saying like turn like this way, you're saying you have some space and you're saying I want you to go to this point. Something that seems maybe relatively simple. It has a lot of applications of like robot control and just the basis of like so many of the things we do here. For some of the more details, we're going to hold these workshops over the next around 6 weeks. It's going to be from like 1 hour to 1.5 hours of instruction each time. It's only once a week, so it's really not that huge a time commitment, hopefully for you. It's definitely going to be a lot of fun, and it is taught by, as I said, very I think everyone here that's presenting is pretty skilled in what they're talking about. It's people that have had experience and want to pass on this information to others. And so we're going to be covering a lot of things. I'll just run through the topics so you can see them right here as well. You have CAD, which is computer-aided design. You have 3D printing. You have Intro to Python. You have A-star search algorithm, and you have forward kinematics. Bennett will cover more of those computer science topics later on. I'll get 2 more points for this slide is that, as you can see from the top bar, and I've tried to reiterate this point, numerous times, is this is meant for, beginners, intermediates. I mean, anyone that's interested. That there's stuff in the computer science track that, I'm mechanical engineering. I've never done the computer science stuff before, and I've had the experience to go through. And when I go and do the code aspect of things, it's like I never realized how this worked. I never, I gained so much knowledge, even as someone who I like to think of myself as, pretty knowledgeable, but I had no clue about computer science topics. And so I think there's something in it for everyone. And the other point is that, what else was I going to say? That the arm itself is, you can see, and you'll see this from all the topics we go through, that like creating this project is like, you'll get a little piece of everything, which I do really think is great. And it's really comprehensive introduction to like just general robotics. You can go next. So these are these will be your instructors if you choose. One of them is me. I will be teaching the Intro to CAD and 3D printing workshops, two things I hold very dear. Fran will be doing the How to CAD, and then Bennett will be doing Intro to Programming, Forward Kinematics, and Planning with A-Star. We actually had a fourth member of this group, but he's actually, this is pretty cool, he's actually studying at Carnegie Mellon right now for computer science, which, is a pretty well testament of, he knows his stuff with computer science. And yeah, he had a huge part, Sam Treist. He's an alumni, and he made the project what it is. So huge thanks to him. He'll be in for a few office hours, but other than that, it's kind of one of those things where we want to use everyone's times effectively. So we'll be running, me, Fran, and Bennett will be running the workshops and also the office hours. You can go next. So this is basically the focus of the project. I'm pretty proud of what it looks like now. The physical aspect of things. It's a lot of work by Fran. I did a few finishing details, but other than that, Fran did most of it. And it looks great. And the cool thing is it's mostly all 3D printed. It's basically these two 3D printed plates, a mount, and then two motors. And then same thing, we'll have these little motor mounts, and we'll have a workshop how to put it all together. But the whole point is that it's really not that complex, but it will teach you a lot of things. The other point, I guess part of the thing is will be nice is we're making one right now, the second version. We had a first version, but we'll have one working to show off to people. And I guess that's the more something I should have clarified earlier. This entire thing is going to be over Zoom, so it's all online. But there's a lot to be taught. You might think, I can't physically build it. You will learn a lot from instruction, much like any of your classes. What we're thinking of doing right now is that we'll have one arm put together, and then at the end, when you get your code all done, we could insert your code and run it on the physical arm. In another world, we would have made these and sent them, made them as a group and sent them out to people, but we're still going to teach all of that same content, so you get lots of stuff to learn. Next. So I'm going to pass it over to Bennett to talk about a little bit more about the programming side of this, and give a little bit more details.
Yeah. So there are 3 workshops on the code, as were mentioned. We're doing Intro to Python with Raspberry Pi. That'll also introduce some of the command line tools like Git, which are useful for this. Basically, all of the code is written in such a way that you can install it onto your machine without the ARM at all, and you can run every single example in simulation. On the left here, there's an illustration of forward kinematics, which is basically the idea of, if we're controlling the motors, we can control the angle of the motors, but you need some math to figure out, where will the end of the arm end up, given, the angles of the arm. And I made this in Desmos. It's an entirely mathematical construct here, just kind of proving, okay, yes, the math works out, and then we put it into code later on. In the middle here, it's kind of an intuitive A-star demo. This will be one which you can edit and expand the action set. Basically, right here, this is on a 4-connected grid, so we allow the agent at any moment to go up, down, left, or right. And you'll notice, if it could move diagonally, it could have cut this corner out. And one of the things you'll be able to do is change the action set from 4 to 8 connected. And of course, we'll cover actually what that means. And finally, the same back end of A-star, it works on the arm here. The arm started down here, bent over, and it created a plan, and then followed it over here. And it was planning over the space of the angles, not actually the space of where the arm moves. This is the difference between a configuration space and the operational space. And these are robotics terms. We'll go into them and better explain these things. But I think it's a cool set of demonstrations, and You'll be able to run everything in simulation if you want, or wire code in so that we can put it on a real arm, in person. That wraps up the workshops, I think. Just to add 2 notes about the format. As Joe mentioned, we're doing 1 to 1.5 hour sessions each week. We actually have a form to schedule those sessions, to make sure it works for people. So Joe will post that link in the chat, I think. And if you haven't filled it out and you're interested in these, I would suggest filling it out so we can schedule it at a time that works for the maximum number of people possible. And then second, we mentioned office hours. We'll also put links to these, in an email somewhere. It'll probably be, I think we said Monday evenings, it looked like, but we want to make these things accessible. And if you want to explore extra, maybe you have some questions, maybe you want to, talk about finite element analysis a bit early, we'll have times for these. But this content is created for everyone, so I hope you guys can enjoy it. That brings us to the end. Fill out the scheduling form if you haven't. I would suggest contacting any project leaders you found, to be engaging or interesting. Make sure, join something if you want to. This club is a great place to learn by doing, and the workshops give another way to learn by learning as well. But I think we have a wide gamut of projects from both very accessible to admittedly perhaps advanced. I think that's a good ecosystem, and I hope you guys can thrive in it. So thank you all for your time. I think that's all from us, and if there are any questions, feel free to stick around. Yeah.
Ooh.
Fran, do you have a project proposal form link? Was that updated? We could send it out in the email otherwise.
I think we should send it out the email. I have a few things.
I'll end the recording here. We'll send out an email with all this information, with the recording, with the slides, and with any other final points we remember. But yeah, it's all from us.
Thank you.